my submission for the final project for machine learning foundations for product managers. This is my quick demo for the final project. So the problem that we were posed with was to build a model to predict the electrical energy output of the combined cycle power plant, and we were given a bunch of features here. So I'll quickly go over it. Since the goal was to predict the electrical energy output, um, I've concluded that I'll be building a regression model because we need to predict the output value. So this is a regression task for us. And I've decided to go with the Python code for this. Uh, Not going too much into the code, decided to import a few libraries, load the data into a data frame, see what if the data frame was correctly loaded, plot the final target variable, which is the power and energy output. Um, and then I did some data splitting here where I split the data into a, a training set, a fixed validation set, and a test set. And we're doing this to make sure that we're not overfitting or doing anything like that. And for the model choice, I've gone with three different types of models. First one is linear regression here. So for linear regression, we know that we need to normalize our variables first to build a good model so that we don't have some imbalance based on the feature values, which might look differently because of different units. So I do standard scalar normalization, plot the values to make sure that everything is normalized correctly. Do the same normalization on my validation and test set, and then I basically build a linear regression model, train it on the training set, and then do a prediction on the validation set and calculate the root mean square error. So root mean square error is my evaluation metric that I've decided to go with. So for linear regression, we see that we have this root mean square error of 17 megawatts, almost 17 megawatts, and then for the test set is 16 megawatt. It's comparable values, so we know that it's not overfitting. The same thing we do for random forest regression, and then third choice for a model is XGBoost regression. So to quickly go over the points mentioned as guidelines, the modeling approach that I've decided to go with is a regression model. The features, I've decided to pick all the features since there are only four. Maybe if there were more, we could have done some feature selection tasks to reduce, drop some features, or maybe add new ones. The possible algorithms that I tried here was linear regression, random forest regression, and XGBoost regression for model building. These were the three models that I decided to go with, and then I also used a fixed validation set. For model evaluation, the metric that I've used is root mean square error. Mean square error because I want to penalize higher error values since energy output is a critical process, and higher errors in this can have major consequences downstream for a company or a team that's building this, right? And root value, and I've taken the root mean square so that the unit of the error is similar to the prediction as a target variable that we have, and it's only for better interpretation while you're presenting the results to some other team or to your leadership. For model interpretation, we can see here that among the three of them, linear regression is doing the best. It has the lowest errors on the validation set and test set. Uh, so I think linear regression is the choice here. But for future improvements, I think we can also do some hyperparameter tuning and some feature selection. Um, just to see how that can impact model performance and then make a decision based on that. So this is my presentation. Thank you.